Now let's move on to a very important and practical part of our ETL process, and that is to transform our data. We always want to transform the data to make the data consistent and to get more out of our data. And that's why from the staging layer, we define certain transformations in our ETL process, and then this transformed data will be loaded into the core layer via insert update operation usually. So that's why we want to first, before we dive into the specific types of transformations, want to have a look at what is actually the goal of our transformations. And that is mainly to create a consolidated view of all of our data that is optimized for our analysis purposes. So first of all, if we have a look at that, we basically have two main goals. The first one is to create a consolidated view. That means we need to integrate data from multiple systems. So this could include different things like data type conversions and column names and different types of standards that we want to set to create a consolidated view. But then also we want to do some additional reshaping that is just there to fit the data to our analytical or reporting needs. So we might want to add some additional information or just reshape the data so that it can be analyzed. And of course, we'll also have a look at that in some examples. But first, consolidated view. What does that mean? So of course we have different systems, and we can see that sometimes in those different systems where we are pulling data from, we can have different types of formats, different types of data types, column names, and all of that we want to bring into one consolidated and standardized view. So for example, we see that in this column we have the amount in thousands. And also the data type then obviously is also different. While we have a decimal number in the lower table, in the upper table we have an integer number. And the same goes for different date formats, and this is all something that we want to consolidate to make the data compatible with each other so that we can load it into one single table. That's very important, of course, in our data warehouse. But on top of that, we also want to reshape the data according to our business requirements. So for example, if we have our table like this initially, of course we want to reshape the data so that we can use it in a dimensional way. This is what we want to do in our data warehouse. And this can include that we, for example, want to include foreign keys. So these are simple reshapings, restructurings of our data. Another example could be that we want to really change the shape of our data in a more drastic way. So for example, we can have some Excel tables and the data is in this form. And of course, this is not very nice to be analyzed because we want to store the data usually in columns and rows. And that's why we sometimes need to have the data available like this. So we could, for example, pivot the data. Of course, this is something that is not so common, but it's just a good example of a stronger and more impactful reshaping of our data. And of course, in this case, we can also see that this total column is also maybe something that we don't want to have included in our final table. And that's why we could just filter that data out. So these are all things to clean, reshape the data to make it fit to our business and reporting requirements. And if we now have a look at the entire list of different transformations, we can see that there are quite a lot of them. And now we, in the next two lectures, want to have a look at both the more basic and also then the more advanced transformations. And that's why in the next lecture, we just want to start with the basic types of transformations that are usually very important. And that's what we are going to do in the next lecture. Let's start with the basic data transformations. And the first thing that we oftentimes need to do is to make sure that there are no duplicates in our data. This is of course also usually the case, or something that we should consider if we have multiple systems. So let's imagine we have data from 2 different stores. And of course, we can have now some of the products available in both of the stores. So we want to create one unified dimension. And of course, that's why we want to append the data so that we have one product dimension. But now, of course, it can happen that some of the products are available in both of the stores, and therefore they would be duplicates. And this is, of course, something that we don't want to have in our dimension tables. And that's why we could just remove those values and basically deduplicate them. This is what we mean with deduplication. So we just take the distinct values of this dimension after we have put them in one table together. Another type of transformation is filtering rows. So it's in a way similar to deduplication, because we in deduplication basically just remove the duplicates, but now we want to remove other values that are also not relevant to us. For example, let's assume we want to create a sales fact table. And in our data that we get out of the source systems, we can have also data that we don't need to have because it's not relevant. In this case, it could be that there's also refund transactions included. So we could filter out all of the data, for example, where the amount is negative, or in our case, we can make it even simpler and just remove all of the values where the data type is refund. So this would be a filter condition that we can use to remove or to filter certain rows. And in that case, of course, we see that all of the values would be in this case of the type sale. And this brings us to the second type of filtering, which is removing just columns that we don't need. For example, in this case, this is really a column that doesn't make any sense because every single value is just sale. And therefore, in this case, we can also just remove it. So we only focus on the data that is really relevant. And something that we also want to do in this stage is to clean the data. So for example, if we get again multiple tables from different source systems, we want to bring them in one consistent shape. So for example, one system could use from our customers the gender, the abbreviation M for male and F for female, and in another system this might be written out. And of course now we want to make one standard. That means we want to map data. So we want to map M to male and F to female, for example. So this means that we can just replace certain values with other values to make our data more consistent. Another thing would be in here that we can also clean the data. So for example, we have some characters included or some things that needs to be, for example, removed or replaced in another way. So for example, in here, there was also one E included, and this is of course then also something that needs to be cleaned, that needs to be removed. So this is something that is very important to integrate our data. Another thing that we need to do is to map or replace nulls, for example. So it could be that we want to, in some cases, replace them with a 0. So for example, if there didn't happen any sales on Wednesdays, this means in our case that there were $0 in sales. So this could be, of course, also dependent on the use case, but this is something that we might also consider. And something that is similar to that is value standardization. This is also important to integrate the data. But in this case, we just have different data types, for example, and we have different units, for example. So in this case, we see that the sales are in thousands. So 1.5 means 1,500. And this is why we should bring them also again into one uniform standard. So like this, we can bring them again all together in one table. So what we could do, for example, is multiply with 1000 and just change the data type of this table into whole numbers. And like this, we can bring both of these tables together into one consolidated view. And last but not least, we've also seen that we usually want to also add a key. And this can be auto-generated either in the database management system or in the ETL tool. And this is then our surrogate key that is the replacement usually of our natural key. So we've learned that this is also something that we want to do and that is advised. So these are now the more basic transformations, but now in the next lectures, we also want to see some of the more advanced data transformations. And after that, we'll also quickly demonstrate a few practical transformations in our ETL process. Now that we have seen the basic data transformations, we also want to see the important examples of advanced data transformations. And we want to start, in our case, with joining multiple tables together. So this is something that is oftentimes necessary to get the foreign key into our fact table, because sometimes we have only a natural key in our fact table. And that's why we add a surrogate key into our dimension table, but now we still need to reference this key as a foreign key in our fact table. So we have only this natural key, and now we also want to bring in this surrogate key for the product dimension. And this is something that we do usually by joining the data. And we use, so if you want to go over the concept of joining again, we've talked about this in the beginning of the course when we talked about relational databases. So if you need a refresher on that, jump back to that lecture. But we want to, in our case, in this example, want to use the product ID as the common column to make a join into our fact table. And with that, we get this additional product foreign key, which is now just referencing this primary key. So for example, 533 is in this table with the primary key 3, and that's why in here we also have the value 3. 252, we have a look, has the value 2. So this basically works like a lookup where we now get also the foreign key into our facts. So this is something that we can do, but sometimes if we talk about slowly changing dimensions, we can also have some effective and expiry date. And this is then also in conjunction with a filtering or a second condition that the date in our fact is in between the effective and expiry date, because otherwise we could get multiple values of the same natural key, but we end up with only one value if we filter the data to only the values where the current date or this transaction date column is in between the effective and expiry date. But this is also more of a specific use case if we are really working with slowly changing dimensions. Otherwise, a simple join will do the job. And of course, also in some cases, we need to just get additional columns into our table. So in this case, we have the product table and the category table in separate tables. But now we want to merge them together and we want to bring it into one compact product table. This is what we want to do to make it more user-friendly, and in this case it's also better for the performance, so that we don't need to do all of the joins always manually, which of course take also compute resources. And that's why we want to make a join using this category column, and then we have one product dimension table that is now a lot better for the users. Another example of a transformation is splitting the data. So let's imagine we have this store dimension, and in this location we basically have three types of information. We have the city, then we have the state and the zip code. And now we want to split the column so that we get these information also in separate columns so that we can use them independently. For example, we can split first by this delimiter of a comma. So always after the comma, we want to extract everything. So in this case, New York. Then again, in the second, we have all of the other cities. And of course, after that, we can again split by a delimiter. So this could be a white space, but also another type would be by length or by position. So that means always at the third position, make a split and put the first characters into the first column and the rest of these characters into another column. So for example, in here, we could say split after 2 characters. So then the first 2 letters would land in the first column and then the rest would land in the other column, the zip code. So these are things that we can do, either splitting by length or position or by a specific delimiter. Another thing that we can do, especially if we want to change the granularity, we can oftentimes aggregate the data. And different ways of aggregating the data could be taking the sum. So for example, in this case, we have the granularity of a single day. And that's why we want to sum all of the amounts of our sales for every single day. But also we want to count the number of sales. So we want to count basically the number of rows, because one row is just the same as one sale, one transaction. But for example, if we also want to understand how many different products we have sold, we can also use things like a distinct count, and then we just get the distinct number of values. But also we can use other aggregations, such as, for example, an average. And last but not least, we can also calculate additional values. So we can subtract things, or we can multiply things, or we can also create groups. And in our case, we just want to calculate the tax amount in an absolute value. So we have, for example, the percentage value, which is not so nice to be aggregated because we cannot sum these values up. We can see it's non-additive, but we can calculate the absolute amount because we have also the sales amount, and with this tax percentage value, we can create this additional column, tax amount, which is basically the product of those 2 columns. And like this, we can get additional information and additional insight by deriving specific values. So these are some of the most important types of transformations. And now that we've learned about those different types of transformations, we also want to implement them and demonstrate this in our little ETL process. So that's what we are doing in the next lecture. Now we are ready to put things into practice, and in this lecture we want to have a look at what exactly are we now going to implement, because now we want to implement that what we have learned in theory already. So we have seen that we have a data source, our product table, and in a way we've already at least partly set up our staging. So we have set up the extract, so we also have added a surrogate key in the database management system, and with our variables we have also defined the delta logic. We still need to output the data that we have gathered in the ETL and write that into our staging table. This we still have to set up, but this will not be so much. And then after we have set up this extract part, we want to now also load the data with some transformations into the core. And the transformations will be some cleaning, and we want to add an additional column. And we quickly also see what kind of column we want to also set up. And this will be then, of course, the transform and load part. So therefore, this will be the overview. And now we want to have a look at the single steps that we now need to implement and have a look at. First, we want to have a look at the data and what the problem is with the data, what parts we still need to clean, and what kind of additional column we want to set up. So this is what we now want to start with. And that's why we want to jump into PG admin. And in here, we just want to first open up the query tool. We can achieve that by going to the databases, and there we can just go to our data warehouse X and open up the query tool. In here we can just write select star from staging.dim product. We want to highlight that and run this command to see how the data looks like. And immediately we can see that the column product name is really not very clean. There are some special characters. We can double click and see that there are some tabs included. So this is not white space, but really some characters that we don't want to have. In this case, this is tabs. And also sometimes, as we can see in here, in the beginning even, we have also some characters, and we want to get rid of that. So this is the cleaning part. And afterwards, we also notice that in parentheses, we have also, in this case, the brand name. And we would like to extract everything that is here in parentheses, because this is better in a separate column, because it's a separate information of our brand. And if we have that in a separate column, we can group the data also by the brand, and like this, it will be much nicer and we have more analytical value in that. So this is the problem. And now, what are the steps we are going to do to solve this problem and continue with the creation of our ETL? That's why let's jump back into our plan of attack. So the next thing that we now need to do is we want to set up the tables and the schema. This is what we define in PG admin. So we want to set up the core layer, and this will be just a schema. So a schema that is called core. It could be also a separate database for our core layer, but we want to just go with a separate schema. In that, we can then set up our table, which will be our product dimension. And then afterwards, we need to still complete the staging layer in the ETL tool. That means that we want to also output the data that we have gathered from the delta. And also note that before every run, we always prior to that need to also truncate the table. That means we want to remove all data from the table. And then once we have finished this extract part, we are now ready for transforming the data and then loading it into the core layer. And this will be done by just reading the data first from the staging. Afterwards, we can then set up our transformations. We have learned we need to clean it, and then we want to extract the data from these parentheses to set up a separate column. And then, of course, last but not least, we want to load that data also into the final table in our core schema. So this is our plan of attack. And now in the next lecture, we immediately want to start with setting up the tables and the schemas and fixing or completing our staging table, so our ETL process. And that's what we are going to do in the next lecture.